Welcome back. You've learned to think like a professional tester. Now it's time to become a bug hunter. In this module, Emma will show you where defects commonly hide, why seemingly perfect features can still fail, and how experienced testers investigate beyond the obvious. By the end, you'll start viewing every feature with a risk-focused mindset, uncovering problems before customers ever encounter them. In this part of Level 1, you'll build your testing skills through 3 practical modules. First, you'll develop the mindset of a bug hunter and learn to uncover hidden risks. Next, you'll follow the complete testing workflow, from requirements to release. Finally, you'll explore common beginner mistakes and the habits that distinguish professional testers. Think of this as your first week working alongside Emma on the Phoenix Bank project. Emma asks, why do customers find bugs that internal teams miss? You guess it's because they use the software more. She smiles and explains that customers behave in unexpected ways. Professional testers don't wait for bugs. They actively search for situations where software is most likely to fail. In this module, you'll learn to question assumptions, investigate risks, and develop the bug hunter mindset. Emma demonstrates a money transfer, and everything works perfectly. When you say the feature looks good, she asks, what if the customer clicks transfer twice? What if the network disconnects? What if another transaction changes the balance? Suddenly, new risks appear. Professional testers know that a successful demonstration doesn't prove quality. It reveals where deeper investigation should begin. The next day, you report something that looks strange. Emma asks, compared with what? She explains that a bug exists only when actual behavior differs from expected behavior, defined by requirements, business rules, or user needs. Personal opinions don't determine software quality. Professional testers compare expected and actual results objectively, using evidence, not assumptions, to decide whether an issue is truly a defect. While reviewing production issues, you notice that defects can originate from many stages, not just development. Some begin with unclear requirements, poor design, integration problems, deployment errors, or production configuration issues. Emma explains that understanding where defects originate helps testers ask better questions, identify risks earlier, and prevent problems before they reach customers. Emma draws a chain showing how a failure begins with a human mistake, becomes a defect in the design or code, and finally appears as a visible problem for customers. Most people only notice the failure, but professional testers investigate the entire chain. By finding the root cause, teams can prevent similar defects in the future instead of fixing the same problems repeatedly. With only 1 day left before release, Emma asks where you would focus your testing. Since time is limited, not every feature can receive equal attention. Together, you prioritize high-risk areas, such as authentication, payments, permissions, and financial calculations, because failures there could impact security, money, and customer trust. Professional testers measure success by reducing risk, not by the number of test cases they execute. Emma explains that a login request involves far more than the screen. It passes through the user interface, business logic, validation, APIs, authentication services, databases, and other integrated systems before reaching the customer. A failure at any layer can cause the same login problem. Professional testers look beyond the interface, understanding how system components interact to identify where defects are most likely to occur. Before ending the day, Emma writes 2 words on the whiteboard. What if? She challenges you to ask that question about every feature. What if the network disconnects? What if the user refreshes the page or enters unexpected input? What if 2 requests arrive at the same time? Every what if reveals another potential risk. Professional testers don't just ask whether software works, they ask under what conditions it might fail. Emma asks the team to test the same money transfer feature, yet everyone identifies different risks. A new customer struggles with the interface, a power user values speed, An administrator checks permissions, a support engineer considers customer issues, and a security specialist looks for vulnerabilities. Emma explains that every user has a different perspective. Professional testers intentionally think like different users because each viewpoint can uncover unique defects. The product owner asks, if only one feature could fail today, which would hurt the business most? The team immediately chooses money transfers and payroll processing. A typo on a help page is minor, but a payment error could impact customer trust, compliance, and company reputation. Emma explains that professional testers prioritize testing by business impact, ensuring limited time is spent protecting the features that matter most. Emma gives you an unusual challenge. Stop thinking like a customer. Think like an attacker. She explains that professional testers look for ways a system could be abused before real attackers do. Could someone guess passwords repeatedly, bypass validation, or gain unauthorized access? You don't need to be a security expert, but adopting this mindset helps uncover security risks early and better protect users. The login feature works perfectly until Emma shuts down a back-end service. Although the interface still loads, authentication fails because a dependency is unavailable. She explains that customers only see a system that doesn't work, regardless of whether the cause is the application, database, API, or network. Professional testers therefore verify not only successful scenarios, but also how well the system handles and recovers from failures. Emma points to the transaction history and asks, where does this number come from? Together, you trace the data from user input through validation, business logic, the database, and back to the screen. At every step, errors such as missing, duplicate, or incorrect data can occur. Professional testers verify not only what users see, but also how data flows through the system to ensure accuracy and reliability. Emma warns that intuition alone isn't enough. She introduces a bug hunting framework, a checklist covering infrastructure, data flow, validation, business rules, system behavior, security, logging, and recovery. Instead of randomly exploring the application, you examine each area systematically. This structured approach reduces missed risks, even under tight deadlines. Great testers don't find bugs by chance. They follow repeatable methods that consistently uncover hidden problems. Emma gives you a checklist instead of a test case. Rather than steps, it asks questions. Is input validated? What if the network fails? Are permissions enforced? Can duplicate requests occur? Are actions logged? Is recovery handled correctly after errors? She explains that experienced testers remember better questions, not more test cases. Start every new feature by asking the right questions. They naturally lead to stronger test scenarios. Emma assigns you the money transfer feature without a single test case. Instead, she asks you to identify potential defects and both business and technical risks before opening the application. You apply everything you've learned, thinking about different users, business rules, infrastructure failures, data quality, security, and unexpected behavior. The lesson is clear. Professional testing begins with risk analysis, not with clicking buttons. After reviewing your work, Emma highlights common beginner mistakes. Many testers focus only on the happy path, forgetting boundary values, permission checks, integration points, and error handling. These mistakes aren't caused by a lack of ability, they result from incomplete thinking. The bug hunter mindset teaches you to slow down, question assumptions, and deliberately explore scenarios that others are likely to miss. Before moving on, Emma shares the checklist she uses for every new feature. It covers the interface, inputs, outputs, validation, business rules, permissions, security, performance, logging, integrations, and notifications. Each category helps her uncover risks that are easy to overlook. Like a pilot's pre-flight checklist, professional testers rely on a structured review instead of memory. Great bug hunters succeed through systematic investigation, not guesswork. Let's review the key lessons from becoming a bug hunter. Every feature carries hidden risks, even when it seems to work correctly. Professional testers look beyond the code, focusing on business impact, asking what if, and exploring the system from multiple perspectives, including users, business, infrastructure, data, and security. Most importantly, they replace assumptions with structured thinking. This mindset will guide every testing activity you perform. Now that you've learned to think like a bug hunter, Emma introduces the next challenge. Finding risks is only the beginning, she says. Professional testers also manage their work with discipline. Instead of relying on intuition, they follow a repeatable workflow that turns unclear requirements into confident release decisions. In this module, you'll learn the structured QA process that reduces mistakes, improves collaboration, and helps ensure nothing important is missed. Emma sketches 8 steps on the whiteboard. Understand requirements, analyze them, design tests, execute tests, report defects, retest fixes, perform regression testing, and support the release. Although the workflow looks simple, every step depends on the previous one. Poor analysis leads to weak test cases. Unclear bug reports slow fixes, and missed regression testing creates production issues. Professional testing is a connected process that delivers reliable software. The product owner assigns a new user story for scheduled money transfers. Your first instinct is to open the application, but Emma stops you. Can you explain what the customer is trying to achieve? Realizing you've only read the title, you understand her point. Professional testers don't begin by clicking. They begin by understanding the requirements, clarifying expectations, and learning the business value before designing or executing any tests. Emma now follows the complete testing workflow. Understand requirements, clarify business rules, identify risks, design test cases, prepare test data, execute tests, report defects, retest fixes, perform regression testing, and support release decisions. Notice that execution is only one step. A tester creates the most value through preparation, analysis, communication, and risk management long before testing begins. Emma first collects the user story, acceptance criteria, wireframes, API documentation, and business rules. She explains, requirements are our map. If the requirements are unclear, every test that follows may be affected. She studies not only what the feature should do, but also why it exists and the customer problem it solves. Strong testing always starts with a clear understanding of the requirements. Instead of making assumptions, Emma asks questions. Who will use the feature? Are there permission rules, invalid inputs, business exceptions, or external systems? How will success be measured? Each answer reduces uncertainty and improves test quality. She reminds you that clarifying requirements early is much faster and less costly than fixing misunderstandings after development is complete. Emma defines what is and isn't in scope for the sprint. Core business scenarios are prioritized, future features are excluded, and unclear requirements are flagged for discussion with the business analyst. This keeps the team focused and aligned. Professional testers know they can't test everything. They prioritize the areas that deliver the greatest value and reduce the highest risks. Emma evaluates each feature with a simple risk matrix, asking, how likely is this problem? And how serious would the impact be? High-risk features like authentication, payments, and recurring transfers become top priorities, while lower-risk items can wait if time is limited. Risk-based testing helps professional testers focus on the areas that matter most, instead of treating every feature equally. With the risks identified, Emma defines test conditions before writing test cases. For the login feature, she lists scenarios such as valid credentials, invalid usernames, wrong passwords, locked accounts, expired OTPs, and inactive users. These conditions ensure every important situation is covered first, making the final test cases more complete and effective. Before execution, Emma prepares realistic test data. She creates active users, locked accounts, expired OTPs, boundary length usernames, empty values, special characters, and different customer roles. She explains that even excellent test cases can miss bugs if the data is too simple. Professional testers know that high-quality test data is essential for effective testing. With everything ready, Emma begins test execution. She reminds you that testing is more than following steps. Compare actual results with expected outcomes and watch for unexpected behavior, confusing messages, slow responses, or UI issues. Great testers stay observant throughout execution, treating every interaction as an opportunity to discover problems beyond the documented requirements. During testing, you discover that a locked account can still access the dashboard. Emma says, "Great, now help the developer reproduce it." Together, you create a clear bug report with a descriptive title, reproduction steps, expected and actual results, environment details, screenshots, and logs. She explains that finding a bug is only half the job. A well-written report helps developers fix it quickly. A few days later, the developer marks the defect as fixed, and Emma asks you to retest it. You repeat the exact scenario using the same test data and conditions. This time, the locked account is correctly blocked. Emma explains that retesting has one purpose: confirming the reported defect has been fixed. Verifying other features comes later, during regression testing. Although the login bug is fixed, Emma performs regression testing before approving the release. Together, you verify password reset, multi-factor authentication, Remember Me, session timeout, and user profile features. Even unchanged functions can be affected by a code fix. Regression testing ensures existing functionality still works and helps protect the stability of the entire system. As release day approaches, the product owner asks if the product is ready. Instead of answering yes or no, Emma presents the testing results, remaining defects, business risks, test coverage, and regression status. This allows stakeholders to make an informed release decision. She reminds you that testing doesn't prove software is perfect. It provides the evidence needed to reduce risk and support confident decisions. Looking back at your first sprint, Emma highlights common beginner mistakes: skipping requirement analysis, using poor test data, defining an unclear scope, reporting bugs without evidence, skipping retesting, or forgetting regression testing. These are workflow problems, not technical ones. Following a disciplined testing process helps avoid these mistakes and consistently improves testing quality. Emma summarizes the testing workflow: understand requirements, ask questions, define scope, assess risks, design test conditions, prepare data, execute tests, report defects, retest fixes, perform regression testing, and support the release decision. You realize that execution is only one part of testing. The greatest value comes from careful planning, analysis, communication, and informed quality decisions throughout the project. Before ending each day, Emma reviews a simple checklist. Do I understand the requirements? Is the scope clear? Have I identified the key risks? Is my test data ready? Do I know the expected results? Am I ready to collect evidence if defects appear? These questions take only minutes, but prevent costly rework. Professional testers build quality through consistent, disciplined habits. Congratulations! You've completed the professional testing workflow. You now understand that great testing begins with analysis, not execution. From understanding requirements and assessing risks to preparing data, reporting defects, verifying fixes, and supporting release decisions, every step contributes to software quality. In the next module, we'll explore the most common mistakes new testers make and how to avoid them before they become habits. You've learned to think like a bug hunter and work like a professional tester. Before Level 1 ends, Emma shares one final lesson: mistakes. Every QA engineer makes them. By learning the most common beginner mistakes now, you'll build better habits, avoid costly errors, and grow faster. Emma writes 2 words on the board: knowledge and habits. She explains that technical skills are easy to learn, but professional habits take time. Reading requirements, asking questions, verifying results, and communicating clearly are what build trust. Skills help you test. Habits build a successful QA career. During your second sprint, you start testing a new feature without reading the requirements. Emma asks, "What problem does this feature solve?" You don't know. She explains this is the click and hope approach. Professional testers understand the requirements first, then begin testing. Understanding prevents wasted effort and costly rework. Your login test passes, and you move on. Emma asks, what if the password is wrong? The account is locked? The OTP expires? You realize you've tested only the happy path. Professional testers also validate failures, edge cases, and recovery scenarios because real users make mistakes every day. The money transfer screen works perfectly, so you approve it. Emma asks you to transfer more than the daily limit. The system still requests SMS OTP instead of smart OTP. The interface is correct, but the business rule is broken. Professional testers verify both the user interface and the business logic behind it. Emma reviews your test data and sees you've used only valid inputs. She asks, how will you find boundary defects? Together, you test empty values, invalid data, locked accounts, and expired OTPs. New defects appear immediately. Great testing depends on realistic, diverse test data, not just good test cases. You submit a bug titled transfer error. The developer asks, which transfer? How can I reproduce it? Emma explains that finding a bug is only the beginning. Professional testers write clear reports with reproduction steps, expected and actual results, and supporting evidence. Good bug reports lead to faster fixes. During exploratory testing, you spot an error, but the page refreshes before you capture it. Later, the developer can't reproduce the issue. Emma reminds you to collect screenshots, recordings, logs, or timestamps whenever defects appear. Strong evidence builds trust and helps the team investigate and fix bugs faster. A developer says the bug is fixed. Emma asks you to verify it before closing the defect. You repeat the original steps, check the expected results, review the API response, and confirm the database update. Only then do you close the bug. Professional testers verify with evidence, not assumptions. After a login bug is fixed, the team celebrates. The next day, customers report that forgot password and remember me no longer work. Emma explains that every code change can affect existing features. That's why professional testers always perform regression testing to ensure the fix works without breaking anything else. Near the end of the sprint, you notice an acceptance criterion doesn't match the system. Near the end of the sprint, you notice the acceptance criteria don't match the system, but you stay silent. Days later, the team discovers everyone interpreted the requirement differently. Emma explains that late communication causes costly rework. Professional testers ask questions early, raise risks quickly, and help prevent problems before they grow. At the sprint retrospective, a junior tester proudly reports finding 30 defects. Emma asks, how many actually reduced business risk? The room falls silent. She explains that great testers aren't measured by bug counts, but by the value they create. The goal isn't to report more defects, it's to prevent serious problems and help deliver software customers can trust. Before every release, Emma reviews the same checklist: requirements, business rules, happy and exception paths, test data, evidence, and regression risks. She explains that experience isn't about memory, it's about discipline. A simple checklist helps professional testers stay consistent and deliver quality, even under pressure. Emma asks what has changed since your first day. You realize you now read requirements first, ask better questions, collect evidence, and verify every assumption. Emma smiles and explains that great testers are built through consistent habits, not talent alone. Small actions repeated every day are what separate experienced QA engineers from beginners. You've completed part 2. You've learned to think like a bug hunter, follow a professional testing workflow, and build the habits of great QA engineers. These fundamentals will support every testing technique you learn in the next modules. Congratulations on completing part 2 of Think Like a Tester. You've progressed from simply finding defects to understanding how professional testers think, work, and collaborate throughout an entire software project. More importantly, you've started building the habits that create consistent quality and earn the trust of your team. In part 3, we'll take the next step by exploring modern quality engineering practices and applying everything you've learned through practical workshops and real-world exercises. Thank you for learning with us, and I'll see you in the final chapter of Level 1.